Okay, paper 2, question 1. Let's go to a calculator page. We're going to do this question two different ways. We're going to first of all do it using numbers and decimals, and then we'll use the finance solver. So we're being asked to, for the value of £1,000, invested at compound at 2.5%, so we're going to be multiplying by the decimal 1.025 over a period of 6 years, so we raise that to a power of 6, and we get the value of 115969. So that would be the value after 6 years. That's part A done. For part B, we're looking to find out when 1000 multiplied by 1.025 to the power of, and let's say n, is going to be greater than 1500. Now when I press enter, it's going to give me an error because it doesn't know what n is, and I can't solve that equation because it's not technically an equation. But what I can do is, if I change the equality sign to equals, we'll find at the moment in time when it's equal to 1500 and then take it from there. So again, when I press enter, it'll give me an error because I will now want to do menu, algebra, numerical solve that expression for n, just pasting it in by highlighting and pressing enter, and I get the value of 16.42. So let's be clear, if I was 16 years, it would be probably less than 1500, and if it was 17 years, it would be a little bit more. So what we can do is we can check that. I'm just going to paste in the expression, that expression, and I'm going to do control equals given that n is equal to 16, and this should be a value less than 1500, which it is, and when I paste it in again by pressing enter and change it to 17, it's greater than 1500. So in answer to the question, the number of years after which the account first exceeds would be 17 years. Alright, so there's how we could do decimals. Let's show you how you can use a finance solver to do the same task. What we do is we press menu, choose finance, and do finance solver. So for part A, the number of payments, we're going to go for 6 payments, effectively 6 years. Tab down, the percentage rate is 2.5%. And the present value, well, you'd be tempted to type in 1000, but you need to know for the finance solver here that if you're dealing with an investment, the present value is a negative number, so it would be negative 1000. And if I go down to the future value, just tab down to that field, pressing enter will now calculate the future value of this investment for 6 annual payments of 2.5%. So when I press enter, I get the same values I had a moment ago, 1159. So you can just write that number down and you can see that it's beyond 2 decimal places, but we'd round to 2 decimal places because it's money, or we could go to 3 significant figures according to the IB instructions. Now for part B, this future value we'd like to be 1500, and I'm just going to go back up to the top of the table and just press enter here, and it'll tell me how many payments it will take to turn the investment from £1,000 into 1500. Pressing enter gives me that same decimal as 16.42. So again, we know that 16 will be less than 1500 and 17 will be greater. So you can use the finance solver to do all these calculations. It's a little bit more of a mystery of what's going on behind the scenes compared to, for example, what we did first time round. We're done.